You think you know what things are made of. Wood is made of wood. Metal is made of metal. Water is water. It's all very sensible until you ask what those things are made of. Then you say atoms. Fine. But what are atoms made of? And here's where it gets uncomfortable, because the honest answer is, I don't know in the way you want me to know. Let me be clear about something right away. When you ask what something is made of, you're really asking me to describe it in terms of something more familiar. Like if I told you a table is made of wood, that satisfies you because you know what wood is. But if you keep asking what wood is made of, eventually I run out of familiar things. Eventually I get down to things that just are what they are, and I can't explain them in terms of anything simpler. So when you ask what the universe is made of, you're asking me to bottom out. You want the fundamental stuff, the things that aren't made of anything else. And here's what bothers most people. Those fundamental things don't behave like anything you've ever seen. They don't act like little balls. They don't act like waves in water. They don't act like anything ordinary at all. Start with what we can say for certain. Everything you see, everything you touch is made of atoms. That much we know. We can see them now with special microscopes. We can count them, move them around one at a time. Atoms are real. But an atom isn't a thing the way a marble is a thing. An atom is more like a pattern, a structure of something else. Inside an atom, you've got a nucleus at the center. That nucleus is incredibly tiny compared to the whole atom. If the atom were as big as a football stadium, the nucleus would be like a grain of sand at the center. But that grain of sand contains almost all the mass. The rest is just empty space. Except it's not empty. And that's where everything gets strange. Around that nucleus, you've got electrons. Now, everyone wants to know, what is an electron? Is it a particle? Is it a wave? And the answer is, it's neither. It's something that sometimes acts like a particle when you measure it one way, and sometimes acts like a wave when you measure it another way, but what it really is, we can't picture. We literally cannot make a picture of it that's accurate. Here's what we can do. We can write down mathematical rules that tell us exactly what an electron will do in any situation. Those rules work perfectly. We can predict everything. But when you ask me to describe what's actually there, I can't give you a picture that makes sense. The electron isn't in one place. It's sort of spread out, but not like a cloud. It's there and not there at the same time. It's described by a wave function, which is a mathematical thing that tells you the probability of finding it in different places. The nucleus itself is made of protons and neutrons, and those are made of quarks. Quarks are held together by gluons, and here we are at the bottom as far as we know. Quarks, electrons, photons, gluons, and a few other particles. That's it. That's what everything is made of. 6 kinds of quarks, 6 kinds of leptons, and the force carriers. Fewer than 20 fundamental particles. And that's the whole universe. But what are those particles made of? Nothing. They're not made of anything. They're fundamental. They're the things that other things are made of. And when you ask what they really are, all I can tell you is how they behave. I can tell you their mass, their charge, their spin. I can tell you what forces they respond to. But I can't tell you what they are in terms of something more basic, because there isn't anything more basic. Now, here's the part that really bothers people. These particles aren't little balls sitting in space. They're excitations in fields. What's a field? It's something that exists everywhere in space and has a value at every point, like the temperature in this room. At every point in the room, there's a temperature. That's a temperature field. An electron is a ripple, an excitation in the electron field that fills all of space. A photon is a ripple in the electromagnetic field. So what is the universe made of? Fields. The universe is made of fields. There's an electron field everywhere, a photon field everywhere, a quark field everywhere. And when these fields get excited, when they have energy in them, that energy appears to us as particles, but the field is always there, filling all of space, even in what we call empty space. And empty space itself isn't empty. This is where it gets really strange. Even in perfect vacuum, with no particles, the fields are still there. And they're not quiet, they're fluctuating. Quantum mechanics says that even the lowest energy state has some jittering, some uncertainty. Virtual particles pop in and out of existence. The vacuum is full of activity we can't see directly, but we can measure its effects. You want to know what all this is made of? Space and time themselves might not be fundamental. They might be emergent, arising from something deeper. We don't know. At the smallest scales, smaller than we can currently probe, space might not even be continuous. It might be made of discrete bits, quantum units, or it might be something else entirely that we haven't imagined yet. Here's what we do know for certain. Everything behaves according to rules. Quantum mechanics and relativity tell us those rules. We can predict what will happen. We can build technologies based on these predictions. Computers, lasers, nuclear power, all based on our understanding of what matter is and how it behaves. So our descriptions work, even if we can't fully visualize what's happening. But let me be honest about the current state of things. We have two great theories. Quantum mechanics describes the very small. General relativity describes gravity and the very large. And these two theories don't fit together. They give different answers about what should happen in extreme situations, like inside a black hole or at the moment of the Big Bang. So we know our current description is incomplete. Some people think there's a deeper theory, maybe string theory, where particles are actually tiny vibrating strings in 11 dimensions. Maybe that's right. Maybe it's something else. The point is, we don't know yet. We're still figuring it out. And that should excite you, not frustrate you. We're at the edge of human knowledge. Here's something crucial to understand. When I can't give you a picture, when I can't describe what an electron really is in familiar terms, that's not a failure of physics. That's not me being a bad teacher. That's nature telling you that your intuition, built from everyday experience with big objects, doesn't apply at the quantum level. Reality at small scales simply doesn't behave like reality at large scales. Think about what that means. Your intuition is built from evolution. Your brain evolved to track predators, throw rocks, avoid falling. It didn't evolve to understand quantum mechanics. So when quantum mechanics seems weird, that's not because it's wrong. It's because your brain is running software designed for a different scale of reality. The amazing thing is that we can understand it anyway, not through intuition, but through mathematics. We can write equations that describe exactly how these fields behave, how particles interact, what probabilities govern their behavior. And those equations work. They make predictions that match experiments to incredible precisions, in some cases to 10 decimal places. So here's my honest answer to what the universe is made of. It's made of quantum fields obeying mathematical laws we've discovered through experiment and theory. Those fields have excitations that appear to us as particles. Those particles follow rules that we can write down precisely, even if we can't picture what's happening in a way that satisfies our everyday intuition. And underneath all that, we don't know. Maybe there's something deeper. Maybe fields are made of something else. Maybe space and time emerge from some more fundamental structure. Maybe reality is computational, mathematical in nature, not made of stuff at all. We're still investigating. We're still looking. But here's what doesn't change. Whatever the universe is made of, it behaves according to laws. Those laws are discoverable through experiment. They're describable through mathematics. And they work the same way everywhere, as far as we can tell. That's remarkable. The universe could have been chaos, but it's not. It follows rules. You might find this unsatisfying. You want me to say it's made of something you can picture, something solid and real, but that's asking me to lie to you, to pretend we understand more than we do, or to pretend that reality at small scales behaves like reality at large scales. I won't do that. The truth is stranger and more interesting. What I can tell you is this: the universe is made of things that interact. Those interactions follow precise mathematical laws. Those laws allow structure to form: atoms, molecules, stars, galaxies, planets, life, consciousness. Everything you see is these quantum fields doing their dance according to those laws. And somehow, improbably, some arrangements of these fields became complex enough to ask what they're made of. That's you, your quantum fields asking about quantum fields. Atoms contemplating atoms. The universe trying to understand itself. If that doesn't give you a sense of wonder, I don't know what will. So when you ask what it's all made of, the deepest answer I can give you is, we're still finding out. We know more than we did 100 years ago. We'll know more in 100 years. But there will always be another question, always something deeper to ask. That's not a bug, that's a feature. That's what makes physics worth doing. The universe is made of whatever it takes to make the universe behave the way it does. And our job is to keep asking questions, keep doing experiments, keep refining our mathematical descriptions, and keep being honest about what we know and what we don't. That's science. Not certainty, but honest inquiry into what's really happening. And if you can't sleep at night because you can't picture what an electron really is, good. You're thinking about it the right way. You're feeling the strangeness of reality. Don't try to make it comfortable. Let it be strange. That strangeness is telling you something important about how different the world is from how it appears. That's where understanding begins. What the universe is made of depends on how deep you want to go. Chemists will tell you atoms. Physicists will tell you quarks and electrons. Quantum field theorists will tell you fields and excitations. And the honest truth is, we're not at the bottom yet. We might never be. But we keep digging, and every layer we uncover is more beautiful and more strange than the one before. That's what the universe is made of. Mystery on top of mystery, all following laws we can discover. Fields we can't see, particles we can't picture, interactions we can describe but not visualize, and somehow it all works together to make everything you've ever experienced. That's not just physics. That's the deepest truth we've found about reality itself.